All right, so this is on polynomial graphs. So you're not going to actually be graphing the polynomial function according to what I looked over. You just have to say what you would get if you were to graph. So first off, the graph of a polynomial function is a smooth curve determined by its degree and leading coefficient. So I think these lines are for what the degree is. The degree, I've said it a couple times in the other videos, is the highest exponent. Now the maximum number of turning points is one less than the degree. So it's the degree minus 1. So what this means is that if the degree is 7, at most your graph is going to turn 6 times, one less than the degree. All right, next is end behavior. So for end behavior, we have this little chart here. Okay, so it's divided into even degrees versus odd degrees, and then positive lead coefficients versus negative lead coefficient. So first off, let's talk about what an even degree positive lead coefficient function looks like. So that would be something like f of x equals, we need a positive lead coefficient, so I'll use 5. And then you need an even degree, so I'll do x squared because 2 is an even number. And then there could be stuff after that. It could be a 7, no, not 7. It could be an 18th power. That's still an even number. All right, so if you think about what this looks like, we know what a x squared looks like. This looks like a quadratic, like so. So that means that the arrows are going to point in the same direction, and they're both going to be pointing upward. So if there's an even degree, the arrows are going to point in the same direction, and both of the arrows are going to be upward if the leading coefficient's positive. Now, if the leading coefficient's negative, f of x equals negative 5x squared, still an even degree, both of the arrows will be pointing downward. So it'll look something like this, right? And if it's a square, it's going to look exactly like that. But if it was like to the 18th power, it's going to have a lot of curves inside of it, but both arrows will still be pointing down. So if there's an even degree, like this, 2 and 2, okay, the arrows are going to point in the same direction. If they are positive coefficient, then they're both going to be pointing up. And if it's negative, they'll both be pointing down. So what you're then going to have to do is talk about the end behavior, what's happening on the ends of the graph. So it's saying as the x values get smaller, so as you look this way on the graph, what's happening to the y values? So if you look at the y values, they're pointing up, so they get bigger, so they're approaching infinity. As your x values get bigger and bigger, what's happening to your y values? That's what this says right here. As your x values are getting, well, this says right here, as your x values are getting bigger and bigger, what's happening to your y values? If you see it's pointing up, they are getting bigger and bigger, so they're approaching infinity. On this one here, as your x values get smaller and smaller, as you look this way, what's happening to your y values? They're going down, so that's negative infinity. And as your x values get bigger and bigger, what's happening to your y values? If you look, they're going down, so that's approaching negative infinity. All right, so that was even degree. So now we're going to look at odd degree. So let's say we have f of x equals, now we have to have an odd degree. So let's do x cubed. And we have to have a positive lead coefficient, so we'll do 5. And we'll do f of x equals negative 5x cubed. All right, so if your degree is odd, your highest exponent is odd, your arrows are going to point in opposite directions. Okay? Now the difference is that if there is a positive lead coefficient, it'd be like a positive sloped line. Now it's going to have curve to it, so I don't want to put a straight line. And it's going to have some curves to it, so I don't want to put a straight line here. But if you were to pull it taut, it'd be like a negative slope line for that one. So this one would be like a positive slope line in opposite direction, like a negative slope line in opposite direction. So if you look here, as your x values get smaller and smaller and smaller, so you look this way, your y values are going down, so they're approaching negative infinity. As your x values get bigger and bigger and bigger, you look to the right, your y values are going up, so that's positive infinity. Here, as your x values get smaller and smaller and smaller, you look left, your y values are going up, so that's positive infinity. And as you look right, your y values are going down, that's negative infinity. Okay. Next couple of things, the maximum number of zeros. So they will ask you how many zeros are there. It's going to be the same as the degree. So same as degree. So if the degree is 5, then the maximum number of zeros is 5. Pass through versus bounce. So if you want to know whether it passes through or whether it bounces, you're going to look at your graph here. This would pass through, this would pass through, this would pass through. This over here is the other graph. This is a bounce, and this is a pass through. This is a pass through. Now that tells you whether you're getting an even or an odd multiplicity, but I'm not sure what he's looking for here yet, so I'll explain it when we get there. All right, relative minimum or maximum. Relative minimum or maximum are the highest and lowest points on your graph, but you can have more than one. So this right here is a relative maximum. It's like a hill. This right here is like a relative minimum. It's like a valley. Over here, this is a hill. That's a maximum. This is a valley. That's a minimum. This is not a hill or a valley, so that's neither. All right. Next is your y-intercept. Your y-intercept is always 0, something, and it is when x is 0, what is y? Okay, you can tell from your equation by plugging in 0 for x, or you can look at your graph. All right, so let's see if we can answer these, and I'll then also know what he is asking for when he asks for those bounce and passes through. All right, so first off, I want to know the degree. The degree is the highest exponent. So if you look, the highest exponent is 3. So the degree is 3. The maximum number of turning points is 1 less than that. So at most, this graph is going to turn twice. The end behavior, so remember, you have to use the first term here. So it's a negative 5x cubed. Holy moly, that's exactly what I picked right here. I cannot believe it. All right, so negative 5x cubed. If you look, this degree is odd. That means the arrows point in opposite directions. Since it's a negative lead coefficient, that means that they point as a negative slope would. So my arrows are going to look like that. But the great news is guess what? You can see it from this picture right here, right? So that's nice, but I don't think that always happens. I think sometimes you're going to have to be able to tell using an equation, right? So my arrows look like that, so now I can fill this in. As x values get smaller and smaller, this is an arrow pointing up, so that's positive infinity. And the other one's an arrow pointing down, so that's negative infinity. But this way, you're going to have to know how to do it, the one where you just look at the equation. All right, next, the maximum number of zeros. It's the same as the degree. It's just 3. So these two are the same answer. And then last but not least, your y-intercept, 0, something. From your equation, all you have to do is plug in 0 for x, plug in 0 here, here, and here. You get 0 minus 0 plus 0 plus 3, so it's 0, 3. From the graph, you look right here, it's 0, 3. Okay, so that's how you do it either way, just in case you have to do both. All right, next, we need the degree on this one, okay? The degree is the highest exponent when it's written in standard form, and this is not written in standard form. So what we have to do is we have to think about getting it in standard form like this. We would have to multiply all this out. But really, we just need the highest degree. So what we're going to do is we're going to multiply this x to the first power times this x to the third power times this x to the second power. So we're going to do x to the first times x cubed times x squared. That gives us x to the 6th power. So f of x equals x to the 6th power, blah, 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 blah. We don't need to know the rest of it. We don't need to know all of this stuff right here, okay? All right, so now let's see what the degree is. The degree is 6. All right, the end behavior. So since it's 6th power, which is an even number, the arrows point in the same direction. Your coefficient is positive 1. So it's going to both be pointing up. So my arrows look like this. My graph looks something like that in between. I'm not sure how, but if you look right here, you can see how it looks. They're both pointing up. So the limit as x approaches, or not the limit, sorry, I was just saying pre-calc way. As x approaches negative infinity, as you look left, as your x values get smaller and smaller, your y values are getting bigger. And as you look right, your y values are also getting bigger. All right, maximum number of real zeros is the same as the degree, so that's 6. Turning points would be 5, but he didn't ask. Next is our bounce points. So I think you have to be able to tell from the graph and from the equation. So let's look at the graph first to see where the bounce points are. So here's a bounce point. That's where the graph bounces, right? And there is no other bounce point. This is a cross point, and this is also a cross point, okay? So there's one bounce point, and it's at -1, 0. If you look at your equation where you can get that from, the -1 comes from this factor, and it's because this is an even number. So it bounces at even factors. That means it passes through at odd factors. So this has an odd factor, this has an odd factor. That means it's going to pass through at 2, 0 from this one and 0, 0 from this one. And if you look, it passes through at 0, 0, and it passes through at 2, 0. Y-intercept, plug in 0 for x and see what you get for y. So you can plug in 0 into your equation, or you can look at your graph. So if we plug in 0 into our equation, we get 0 times 0 minus 2 is -2 to the third power is -8. 0 plus 1 is 1, 1 squared is 1. 0 times -8 times 1 is 0. So my y-intercept is 0, comma 0. Another way of looking at it, it's on my graph right there. Last but not least, your relative maximum. So what you're going to do for a relative maximum is you're going to look for any hills. Here's a hill right here, and then you're going to look at the y value, and that's your relative maximum. So your relative maximum is 2. It's not the absolute maximum because this goes on forever and ever. There should be arrows here. But where on the graph it goes the highest in a certain area. Okay, that's it for your summary, and you can go ahead